this stuff here for that. So if you kind of struggle with some of your practice, remember, use the practice, this time to try and improve your models. If you currently struggle with the principles of local variables, arrays, calling functions, then you should prepare yourself, because this Thursday will build on top of what we've already discussed in this front. And it helps for you to have a very good base of understanding of what you've got so far. So I've watched there some videos around the things that I've done, like historically about using global arrays. Obviously, go look through the videos that are also very good. This is a video where I go through a problem where I'm using basic function calls. And again, you can look at Mr. Artwork's video as well as soon as it's available. But I cannot stress this enough, guys. There's basically a little bit more than a month left for you guys before you graduate. You need to write your exams to graduate. Go strong in this last few months, a month and a half. Go and put all your effort in so that you can do well, so that you can get your degrees, so that you don't have to come back. Alright, so use this opportunity, the class test, the practice, to help boost your mark in comp sci. Right, so that's the first thing, just that notice. Obviously, Mr. Artwork, he continues putting up his videos there. So there's the memo videos and rounding and factors and so forth. So also go through that as well, go through the actual memos that's posted on here, to help you prepare for your Thursday sessions. Right, so that's the one thing. Just the feedback on the semester test is being moderated. I got it back this morning. So the next step is for us to scan, and that is a left, because it's really difficult to scan those things, but you have to do it. So I hope that it's ready for pre-election by around Thursday, Friday-ish, somewhere there. I'm going to, in the meanwhile, try and make 2 videos. Because I don't, unfortunately, have enough time to go through this during class. The videos effectively is I go through the question paper, and I go through each question and what I expected to be answered. Don't see it as a memo, because that's impossible. See it as where you can actually find certain answers and what we typically look for at certain answers. And when you get your question paper back, use that as a formative way in which you can measure yourself. Also measure us and see if we actually mark correctly and stuff like that. All right, anyway. So use that as a learning opportunity to help prepare for your final assessments and so forth. Obviously, semester test 2 will not be on the same content that we had for semester test 1. Semester test 2 is basically chapters 4, 5, 6, and maybe even 7. Because I plan to have basically this week we will finish the process. Whatever the next chapter is, that's what we're doing now. The algorithms and stuff like that, that's going to happen today. And then next week we will finish memory, and maybe even start with virtual memory already. Actually, we're really picking up the pace quite a bit. Right, any questions at this point? Let's go on. Okay, so last week we finished talking. You basically started talking about deadlocks, and we had students here in front trying to take pens and papers and stuff like that. And that basically described the principle of what a deadlock is. And we said that for a deadlock to occur, whenever we use resources, so when the process uses a resource, they typically request it. They will then use it, and then they will release it. So request basically means I want it. Once they've got it, they can then use it, and then they will release it afterwards. That's why also when we talk about processes, one of the characteristics of a process is the open or the resource allocated to that process at that point in time. So that's typically, those are the stuff that they're trying to use, that's open files and all of those things. This brings us just in a formal way, we can say that a process or two processes are deadlocked if the following four conditions hold simultaneously. All of these four things must be true for a deadlock to occur. The first one is what we call mutual exclusion. That basically means that only one process at a time can use a resource. Let's just unpack that a little bit. Think about the memory in your computer. Can more than one process use the memory in your computer? If the answer is no, then you're not right. Okay. Yes, more than one process can use the memory of your computer because it's space. A certain portion of your memory belongs to one process, another portion of your memory belongs to another process. And we've also learned that in some cases processes can share memory. It's possible. So yeah, they can use the memory at the same time. So memory is not a resource that is a problem in this case. But when you open a file, for instance, typically for writing purposes, that open file normally can only be used by one process. Okay, there are ways in which you can work around it, but those are special ways of doing it. So typically also whenever we write, and I tried to mention this a little while ago, whenever we write to some kind of resource, whether it's a file, whether it's a table, whatever, that is when we have this principle of mutual exclusion. So that only one thing can hold that resource at a time. So that's one of the first conditions. The next condition is what we call the hold and wait. Now, if you can remember our demonstration with the students, each one held, the first student held a pen, and the other one held the paper, and they both waited. Because they were waiting for another resource. That's the hold and wait problem, characteristics. Because you have to select multiple resources, so take the one, now take the other as well, then you can complete. But if I take the one and I cannot take the other, then I'm stuck. I have to wait. And if we both are waiting for each other, then that's actually a little bit more continued of what we could call a deadlock. So hold and wait is a big problem. That is one of the conditions. The next one is the no preemption. That means the resource can be released only voluntarily by the process holding it after that process has completed its task. As I've already tried to mention, certain resources are what we call preemptible resources and others are not. Like an open file is a non-preemptible resource. You cannot just take away an open file from. They explain that dots inside a square means the number of those resources. So with R1, the two dots means that there's two of R1s existing. But we can only use resource allocation graphs if successfully to detect a deadlock if we're at the bottom. If only one instance per resource type, then we can actually detect deadlocks or not. If there's more than one resource type, then we can't use resource allocation graphs to detect deadlocks. Right? There's other ways of doing that, but that's not included in the course this year. Historically, we used to do it. This year, we're not going to go through that. So what I'd rather do is I'm going to show you how we use resource allocation graphs, and in that, how you can detect deadlocks. So let's write that here. Alright, good. So there I've got a very basic situation, kind of describing the situation which we had here last week, Wednesday, where we had two processes. So there we've got process 1. Process 1 requests resource A and holds B. So think of it, one student was holding the pen and they were requesting the paper. The other process is requesting B, means requesting the pen, and it holds A, which might be the paper. So that is the typical situation. let's graph this situation.